चलो वापस. अच्छा, this is the carbon cycle. अब मुझे बताओ कि इनमें से कौन सा प्रोसेस है जो probably आजकल बहुत ज्यादा हो रहा है, जिसकी वजह से कार्बन डाइऑक्साइड गैस जो है वो ज्यादा प्रोड्यूस हो रही है, मतलब कार्बन डाइऑक्साइड की क्वांटिटी इंक्रीज होती जा रही है. What is that process that's producing more and more carbon dioxide?
Combustion.
ठीक है, that's combustion. क्योंकि पहले combustion नहीं होती थी. आप ये fossil fuels वगैरह होते नहीं थे, बल्कि पहले उल्टा काम होता था. होता ये था कि जब शुरू में अर्थ की एटमॉस्फेयर जो थी ना, उसके अंदर कार्बन डाइऑक्साइड बहुत ज्यादा थी. प्रॉब्ली 100%, 80%, 90% थी. फोटोसिंथेसिस हैपेंड. फोटोसिंथेसिस ने कार्बन डाइऑक्साइड कन्वर्ट कर दिया किसमें, ग्लूकोज और मॉलिक्यूल्स, और प्लांट्स और ट्रीज बने. और एंड ऑल ऑफ द after photosynthesis happened for billions of years, all of the carbon dioxide, it got locked into these fossil fuels. तो आपकी एटमॉस्फेयर के अंदर ना, क्योंकि जब ट्री बनता है ना, ट्री के अंदर जितना भी कार्बन होगा, कार्बन डाइऑक्साइड विल गेट कन्वर्टेड इनटू ग्लूकोज, और उससे फिर ट्रीज वगैरह बनेंगे. ट्रीज, एनिमल्स ट्रीज को खाएंगे, एनिमल्स बनेंगे. ऑल ऑफ द dead trees and dead animals, they got converted into fossil fuels, and all the carbon dioxide got locked into these fossil fuels into the earth's crust. तो ओवर टाइम कार्बन डाइऑक्साइड की क्वांटिटी कम होती गई, इतनी कम होती गई कि इट्स नाउ लेस देन 1%. ठीक है. बट देन व्हाट हैपेंड वाज कि वी डिस्कवर्ड फॉसिल फ्यूल्स, और हमने जमीन से ना फॉसिल फ्यूल्स निकालने शुरू कर दिए, एंड देयर वाज एक्सेस कंबशन दैट वाज हैपनिंग, एंड ऑल ऑफ दैट गॉट कन्वर्टेड इनटू, or is being converted back into carbon dioxide. तो वो कह रहे which तो वो कह रहे कि the three processes in the carbon cycle are methane reacts with oxygen to produce carbon dioxide, so that's combustion. That's number one. Second is carbon dioxide and water are absorbed and used by plants to make oxygen. ये कौन सा process है?
photosynthesis.
ठीक है, that is photosynthesis. So इसलिए, और फिर last one is respiration. ठीक है, so it's going to be A. ये बस कार्बन साइकिल में ना, although this is not discussed, but remember ये थोड़ा fossil fuels का ना रोल याद रख लेना कि मतलब 3 प्रोसेस हैं कार्बन साइकिल में. बस ये याद रखना कि पहले कंबशन नहीं होती थी, तो ऑल द कार्बन डाइऑक्साइड आफ्टर इयर्स ऑफ फोटोसिंथेसिस, वो सारा डेड प्लांट और डेड एनिमल्स जो है अर्थ की क्रस्ट में, दे अक्यूमुलेटेड एंड दे फॉर्म फॉसिल फ्यूल्स. तो सारा कार्बन जो है ना उधर चला गया, और अब हम उसको दोबारा बाहर निकाल रहे हैं. तो ये जो कंबशन वाला जो पार्ट है ना, दैट इज द वन दैट्स काइंड ऑफ न्यू नाउ. जो लास्ट कपल ऑफ सेंचुरी से ना वी आर कंबस्टिंग थिंग्स. I said the next one is you're in the Haber process. What conditions? तो वो कह रहे हैं कि yield. How do you increase yield? How do you push the equilibrium in the forward direction? इसमें ली Shatter principle. Increase pressure करोगे, which side is going to be favored?
Less molecules.
Yes.
Less gas mole side. ठीक है. Remember, it's not moles but gas moles. आप उसको compress कर. वालेकुम सलाम. You're basically compressing it. So if you increase pressure, less gas mole side is going to be favored. It's going to move to the forward direction. So high pressure. And temperature. It says it's an exothermic reaction. The forward is an exothermic reaction. It's stated clearly over here. So higher temperature, lower temperature.
Lower temperature.
Okay, so it's going to be lower temperature. Remember the rules for Lee-Shatler principle. Lower temperature is going to favor exothermic. दो rules याद रखने सबसे main. Increase pressure, तो less gas. Decrease pressure, more gas. Lower temperature, exothermic is going to be favored. Higher temperature, endothermic is the one that's going to be favored. So remember these rules. अच्छा, उसके बाद next one is so it's going to be B. And simultaneously, there's another question that usually comes with this, and that question is, okay, why would you not use a very low pressure?
Because the process is slow.
Sorry, low temperature की बात कर रहा हूँ. ठीक है, the process would be very slow. Although you're going to get more NH3, but you're going to get more NH3 after a very long time. And the other part is why do you use high pressure? The reason you're going to use high pressure is that so why would you use a very high pressure? Very high pressure में क्या मसला है?
Sir, reaction can be endothermic.
नहीं, very high pressure. What's wrong with using? I mean, yield बढ़ेगी ना high pressure पे. But what's practically wrong with using very high pressure?
Endothermic reaction, a lot of heat will be produced.
नहीं, still not. Uh, मैं explain कर देता हूँ. In practical terms, industrial terms, the problem with very high pressure is that it's expensive. Although अच्छी चीज है, high pressure के ऊपर the yield would be higher. Forward reaction, less gas mole side would be favored. Plus higher pressure के ऊपर the particles are close together, so they would be reacting with each other at a much faster rate. But the whole problem is that it's going to be expensive and dangerous as well. I mean, things could explode at high pressures. So, so high pressures is a good thing, but not practical. So you're not going to use very high pressures. Or low temperature तो पहले discuss कर चुके हैं कि it's going to decrease the yield. That's the next one. 32. Which process used to prevent iron from rusting involves sacrificial protection?
Galvanizing.
ठीक है, that's galvanizing क्योंकि उसमें what happens is कि you have a piece of iron and you coat it or simply provide an electrical contact with a piece of zinc, or it could be magnesium as well. Zinc being more reactive would tend to lose electrons because it's more reactive. It will get oxidized, so it's going to produce these electrons, and all these electrons would travel to iron. Now, in the presence of these electrons, iron would not be able to lose electrons. Because zinc uski taraf na, zinc is sending those electrons towards iron. Okay, there's a constant flow of electrons from zinc to iron. So if oxygen comes over here and it's a non-metal, non-metals try to gain electrons. So all these electrons are not actually coming from iron, they're actually coming from zinc. So zinc जो है ना वो oxidize होते जा रहा है, nothing is happening to iron. So next one is students suggest three uses of calcium carbonate. तो limestone के ये uses हैं. It's used to manufacture cement. It's also used in the manufacture of iron, and it's also used for treating. Just a second. एक second, let me. अच्छा चले. All these three processes are important calcium. The process that involve calcium carbonate. Starting with the first one, let me discuss the first one. Calcium carbonate, remember, is decomposed. This is limestone. This is marble. ठीक है, calcium carbonate is limestone. It's marble. Chalk is calcium carbonate. All of them are calcium carbonate. What you do is you decompose calcium carbonate to form lime, which is calcium oxide. Now, this calcium oxide plays a very important role in cement. What it does is, okay, you turn it into calcium hydroxide. You add sand to it, and this is known as wet cement. Okay, there's a lot of other things as well, but calcium hydroxide plays a very important role in this. फिर उसको आप dry करते हो. What happens is okay, it reacts with the carbon dioxide in the air and turns back into this calcium carbonate, which is the much harder and the stronger form of well, the calcium carbonate is marble. It's pretty strong. So that is what happens when cement dries. So it's used in the manufacture of cement. It turns you use lime to manufacture cement. When you add water, lime is produced and carbon dioxide reacts with it. It's a base. This is an acidic gas and turns into calcium carbonate, which is insoluble and which is very strong. So that's how cement works. Iron ke andar, what was it doing in iron? In iron, what it was doing was you had a blast furnace, Uh, and in the blast furnace, you added calcium carbonate, and again, it would decompose because of the high temperatures to form calcium oxide. And calcium oxide was this basic oxide, metal oxide, and it would react with it would react with sand, SiO2. That was the impurity, and it would form calcium silicate. Sand is a non-metal oxide, and it's an acidic impurity. So what would happen was that slag would form. So on top of so in the blast furnace, when you had iron, you were obtaining iron. On top, there was this layer of slag that would form on top of it, and that layer would be skimmed off. So it was used to remove impurities in the manufacture of iron. अब है alkaline soil के अंदर भी use होते हैं. नहीं, that's wrong actually. You don't treat alkaline soil, acidic soils treat करते थे. So the third one is wrong. Okay, due to acid rain, the soils would become acidic. So calcium oxide or calcium hydroxide would provide OH ions that would react with the H plus one to form water, and they would neutralize those soils. So the third one is wrong. 1 and 2 are the ones that are correct. Okay, is this clear? Hamza, clear? hai? So I do remember doing. I think we did manufacture of iron somewhere just recently. So this one. One of the reactions used in manufacture of sulfuric acid is shown. So let's study sulfuric acid in detail. Okay, what happens? What happens in sulfuric acid, and how do you manufacture it? So that's the contact process. Okay, just for the sake of revision, there are three reactions, and this is another process that you have to remember all of it. What you do is you burn sulfur first, you react it with SO2 oxygen and produce SO2. Second step, the SO2 reacts with oxygen again and you turn it into SO3. And that's very hard to do. You need a catalyst for that. You need 450 degrees centigrade temperatures required for that. And 1 to 3 atmosphere pressure is also needed for this reaction. Once SO3 is formed, ठीक है, remember, and this is an equilibrium reaction, double arrow. So once you have SO3, this SO3 is then reacted with concentrated H2SO4, and it ends up forming oleum, which is H2S2O7. And in oleum, you dilute the oleum, you add more water to it, and when you do that, it forms two molecules of H2SO4. So that's how you're going to dilute the oleum. Hamza, this completely has to be remembered. I mean, there are 4 processes that need to be remembered in a lot of detail. Okay, there's a, but I'll add zinc to it. Remember the contact process. That is one that needs to be remembered. You have the Haber process. That's another one that needs to be remembered. You have, अच्छा उसके बाद you have metals की extraction के अंदर there's extraction of iron. And there is extraction of aluminium. Okay, check your notes. These 4 processes, they have to be remembered in all their details. Okay, and the last one is extraction of zinc. That's a small one. So these 5 things, they have to be remembered in complete detail. So coming back to this, okay, what is the catalyst? It's vanadium 5 oxide. That's the one that's used. And I'm going to add some things as well over here. Okay, what's the purpose of making sulfuric acid? You use it in lead acid batteries, and you use it to make fertilizers. Uh, just remember these two. What's and you'll also be asked to tell the uses of SO2. Remember, SO2 is a bleaching agent. It's used to bleach wood pulp. Plus, it's a good reducing agent. It's used in food preservative. I said next one, 35. Ethanol is made on an industrial scale by fermentation of sugars or by the reaction of ethene with steam in the presence of a suitable catalyst. What is a disadvantage of making ethanol from ethene rather than by fermentation? So he's asking for the disadvantage. Uh, so the first one, part B, a non-renewable raw material is used, which is a disadvantage. Okay, ethene, where do you get ethene? Ethene is obtained from petroleum. Methane, etc. These are all gases that are obtained from petroleum. So that's a non-renewable source. So so that is a disadvantage, and that kind of looks correct. Uh, what is how is ethanol made from fermentation? You ferment glucose. Glucose is a renewable source. Okay, you let's say you take sugar cane and you ferment it. You take organic any other source of carbohydrate, and you can grow those plants again. So so fermentation is renewable. I said this is an advantage. With ethene, the product is pure. With fermentation, the product is not pure because what happens in fermentation is you take a natural product like uh, like glucose. Now that has a lot of impurities. Like it's going to be a juice. Okay? For example, if you take grapes, the source is grapes. Now grapes have not just glucose; they have a lot of other things as well. So when it turns into ethanol and you ferment it by adding yeast under anaerobic conditions, there would be impurities in it, lots of them, lots of impurities, and you would have to distill it to purify it. So alcohols produced using fermentation, that's not going to be very pure. ठीक है? Uh, and you would have to distill it to get a pure ethanol molecule. And the other problem with this is that ethanol produced is not going to be a lot because as soon as ethanol is produced, it kills the yeast that is producing it. So a very tiny amount of ethanol is produced. So so there's lots of things that are wrong with fermentation. It's not a good process, but the advantage is that the things that you use to make ethanol from when fermentation, those things are renewable. You can always grow them. ठीक है? They're basically glucose that are obtained from fruits and plants. So the product is very pure is an advantage from ethene because in ethene you're always going to make ethanol. That's it. The rate of reaction is very high. That's also an advantage. The rate of reaction of fermentation is actually pretty bad because it takes years for fermentation to happen, and you can't even increase the temperature. You have to keep it at 25 uh, because otherwise the yeast would die. So so everything fermentation has a lot of disadvantages except for one, which is that it's renewable. Is this clear? You सारों को clear?
Yes.
I said next is 36 with statement about compounds in the same homologous series is correct. So homologous series is a family of organic compounds having a lot of similarities. There are 5 different points. कोई एक मुझे राफे, what are the 5 points of a homologous series? या कोई भी बता दे कि what are the 5 properties of a homologous series? If you put compounds in the same family of organic compounds, what would they have similar? Number one क्या होगा? कोई भी बता दे मुझे.
Sir, maybe functional group?
ठीक है, one is functional group, like all alkenes are going to have double bonds. ठीक है, that's one. Revise करें. What's the second one? They all have the same functional group. What about number two?
Similar
Chemical
chemical
properties.
properties.
ठीक है, exactly. एक के बीच में I'm going to add general formula. They'll have the same general formula. They're going to have the same chemical properties. They're going to show trends in physical properties. So the physical properties would be kind of similar, but not identical. ठीक है, so they would show trends in physical properties. Or number five is that successive members differ by CH2. So he's talking about the homologous Cs. They have the same chemical properties. They have the same physical properties uh, because they have. So the first one, they have the same chemical properties because they have the same number of carbon atoms. They don't have the same number of carbon atoms. If you have different alkanes, they have different number of carbon atoms. Methane, ethane, propane, they all have different carbon atoms. So first two are incorrect. They have same chemical properties because they have different number of carbon atoms. No. The reason they have same chemical properties is because they have the same functional group. Like all alcohols, they have an OH group. All alkenes have this carbon and carbon double bond. As a D, they have different physical properties because they have different number of carbon atoms. That's true. K, because we are talking about trends. As the size increases, something happens to the physical properties. Number one, that the melting points and boiling points they increase. फिर और क्या that if the size increases, what else happens is that flammability decreases. And there were a couple of more points like viscosity increases. They become very, very thick. They don't flow very easily. Okay, so you have all these points. Acha, the next one. 37. Increasing the number of atoms in one molecule of a hydrocarbon increases the amount of energy released when it burns. What is the correct order? So less energy. Which one has the least number of carbon atoms? Which one has the most number of carbon atoms? Balki he's talking about the number of atoms. Which one has the least number of atoms? Methane or ethene?
Methane.
And which one has the most number of atoms? Is it ethene or ethane? Which one is bigger? Ethene. It's going to be D. Ethane is an alkane. Alkanes are saturated. That means that all of the bonds are going to be single bonds. So ethane is bigger. उसने number of atoms के ऊपर कहा था कि if you have more number of atoms, there's going to be more energy released when it burns. So ethane is the biggest out of the three. ठीक है, हमजा clear है? Rafi, is this clear? हमजा आवाज आ रही है? अच्छा, अगला क्या? An organic compound P reacts with zinc to produce a gas Q. What are P and Q? अच्छा, so zinc metal. वैसे मुझे बता दो, what would it react with to produce a gas? Metal plus what is going to produce a gas?
Acid.
ठीक है, so metal plus acid is going to produce a gas. And it's going to produce salt plus what gas is going to be produced?
Hydrogen.
ठीक है, H2 gas. We did reactions of this. Ethanoic acid is CH3COOH. That's ethanoic acid. ठीक है, the general formula of carboxylic acid is CnH2n plus 1 COOH. और यहाँ पे I told you कि when you use carboxylic acid general formulas, N has to be taken as 1 less than the number of carbon atoms. Eth में the number of carbon atoms is 2. So you're going to take N as 1. There's going to be 1, C1, H would become 3. So it's CH3, COOH. And I'm going to react it with zinc. So when we were making equations of ethanoic acid as acids, I told you that N wala, OH wala H hai na, that's the one that's going to get replaced to form a salt. So it would become CH3CO minus 1. And Zn2 plus is going to take its place. And according to crisscross, this would become 2. Plus H2 gas is going to be produced. So that's the reaction. अच्छा अब 39 है कि alkanes undergo substitution reactions in the presence of UV light. Which equation represents the substitution reaction of ethane? So, and for ethane, we did substitution. And let me open the ये सारे organic reactions ना हम एक दफा go through भी कर लें. ठीक है, I'm just going to go over carboxylic acids भी go over कर लेते हैं और we can also talk about alkenes. So somewhere at the start we did alkanes like over here. अच्छा ये तो उसकी naming वगैरह थी. And then over here we did alkanes. We talked about their physical properties, that they had low melting and boiling points. They were saturated compounds. They all had single bonds only. And we also talked about alkanes not being very reactive, and they underwent only just one reaction, which was a reaction with chlorine or bromine. So it was chlorination or bromination, known as substitution. In that you needed UV light. What happened was that the Cl would take away the H. So the Cl would take away the H, and it could take any of the H's from the alkane and form HCl. और वहां पे जो जगह खाली होगी ना, वहां पे there is another Cl is going to substitute. So another Cl would come in and substitute it. And this could happen to all of the hydrogens, or it could happen to any of the hydrogens. Okay? So it wasn't a fixed reaction. You could have 4 Cls coming in, knocking out 4 H's and forming 8 Cls. And the H would be substituted by Cl. So there was a substitution reaction that was happening. And that was probably the only main reaction for alkanes that alkanes would undergo. So coming back to the question, which equation represents a substitution reaction of ethane? So it's going to be B. Okay, you have an alkane C2H6. And what will happen is that the Cl2 molecule would come in, and eventually it's going to form. One of the Cl is going to knock out one of the H, form HCl, and there's going to be a Cl that would replace the H. So B is the right answer. Okay, which molecules are natural polymers? And he's given you now proteins are a polymer, and nylon is a polymer. Carbohydrates are not exactly polymers. 1 and 3 are definitely polymers. This is a type of polyester. And I'm going to revise what we did over here when we were talking about polymerization. ठीक है, बिल्कुल एंड में हमने किया था कि I said right at the end we did this. After esters we did condensation polymers, and we talked about polyesters. अच्छा, और मैंने कहा था fats are also a type of polyester, but they're not a polyester. I told you that they were much smaller in size. So you can't really call them polyesters. Polyesters are really, really big. तो molecules किस तरह बनते थे कि you had a dicarboxylic acid and a diol, and you just had to remember this. The OH and H, they would get knocked out to form water molecules, and linkages, ester linkages would be formed between them. So you had these polyesters forming, and then you had polyamides, where you had diamines and dicarboxylic acids, and the OH and the H would be lost. So that would form water molecules. And when water molecules are formed,